Hello Warriors, this is Miss Lemons, and today we're going to continue our two-step calculations or two-step dimensional analysis using the mole. Before you get started, make sure that you have a pretty firm grasp on how to do dimensional analysis for one-step problems. If you don't, please view my other videos that walk through questions 1, 7, 13, and 19 in this same packet. Speaking of which, you need to make sure that you actually have your mole concept packet. Looks a little something like this. Once you have that out, make sure you also have your periodic table out and pencil and a calculator. So let's get started. It says determine the number of atoms of calcium in 1.2337 times 10 to the negative third grams of calcium. So it's asking us to we're starting with, 1.2337 times 10 to the negative third grams of calcium. And it's asking us to figure out how many atoms of calcium there are. So again, we need to pick out our conversion factors. We're trying to find one that goes from grams to atoms. And if we look up here, neither of these two conversion factors go directly from grams to atoms. This one goes from moles to grams, and this one goes from moles to particles or atoms. Nothing goes from grams to atoms. So we actually have to kind of connect these two and use both conversion factors. We'll start by writing the easier one first, Avogadro's number. It's easier because we don't have to think about the numbers that we're putting into the blanks. We're just copying down exactly what we see. The only thing that we're going to be trading out is this X here. That X will be replaced by the symbol for calcium, Ca. Now, I did say we are going to be using the other conversion factor. That's 1 mole of X is equal to a number of grams of X. Remember, this X is going to be replaced by Ca, so 1 mole of Ca is equal to how many grams of Ca? And we can get that value from our periodic table. So let's take a look at our periodic table. Calcium is element number 20. It has a molar mass of 40.08 grams per mole. So if I were to ask you, how much does 1 mole of calcium mass out to be? It would be 40.08 grams. So we're going to be using this value here, 40.08. We're going to plug that into our conversion factor, and we end up with this. 1 mole of calcium is equal to 40.08 grams of calcium. Now, we can go ahead and set up and solve. We're going to be starting with what we know over 1, always. So that'd be 1.2337 times 10 to the negative third grams of calcium. And remember, yes, you do need to have the unit as well as the element label. We know that we're going to be multiplying this by a conversion factor. But we don't know which one to use first. So let's take a look at what we've got. Well, we know that whatever unit is on top here needs to come down. So what's on top must come down, which means if we have grams of calcium on top, we need to have grams of calcium on the bottom. So which one of these conversion factors contains grams? This one right here, the molar mass. So if grams of calcium is on top, we need grams of calcium on the bottom. How many grams of calcium? 40.08 grams of calcium. If we use 1/2 of our conversion factor on the bottom, we have to use the other half on top. So that would be 1 mole of calcium on top. So I know that grams of calcium on top will cancel with grams of calcium on the bottom, but we don't want to stop there, because if we did, we would be left with moles of calcium, and that's not what we want. We want atoms of calcium. So that means we're going to have to multiply by another conversion factor. So we're trying to figure out which one's going to be going in this new fraction. We know what's on top must come down. So if I have moles of calcium on top, I need to have moles of calcium on the bottom over here. So I'm going to write moles of calcium. How many moles of calcium? Well, we already used this conversion factor up, so we can't use it again. But this one has moles, so we know it's going to be 1 mole of calcium. 1 mole of calcium is equal to 6.02 times 10 to the 23rd atoms of calcium. So I've already used 1/2 of the conversion factor. We're going to go ahead and use this second half on top. Okay, so now I know I've set this up correctly because I've got grams of calcium on top canceling with grams of calcium on the bottom, moles of calcium on top canceling with moles of calcium on the bottom, which would then lead me with atoms of calcium, which is exactly what I'm trying to do. So how we're going to do this is multiply across the top to get a new numerator and multiply across the bottom to get a new denominator. So I went ahead and I plugged in 1.2337 times 10 to the negative third times 1 times 6.02 times 10 to the 23rd, and I ended up getting 7.4268874 times 10 to the 20th power. I'm also going to multiply 1 times 40.08 times 1, which is 40.08. I'm not done yet, though, because I need to divide the top and bottom. When I do that, I'm going to move my final answer over here. When I do that, I end up with 1.853012475 times 10 to the 19th. And this is kind of a ridiculous number. So remember, we want to round our final answer according to the rules of sig figs. We always want to match with what we started with. So we started with 5 sig figs. So we want to end with 5 sig figs. So underline your top 5 placeholders, 4, 5, and then round up or down, depending on what that number is. So 1 is less than 5, so we're going to be rounding down, which means our final answer for this is going to be 1.8530 times 10 to the 19th atoms of Ca. And this is your final answer for question number 27.